one of the complaints that a lot of people have about digital audio in general is they'll say, you know, the sound stage doesn't sound quite as open as analog gear. You know, it sounds kind of squished. And I'm not a, you know, golden ears mythology, you know, I use only plutonium tempered cables and I run magic markers around my CDs type of person. I mean, I need more to go on than that. So is there a specification that correlates to that sound stage? Well, there's a couple actually. One is jitter, you know, how stable the clock is. And although I don't have the capacity to measure this, I've heard converters that didn't have you know, low jitter, and you can definitely hear what people describe as a smearing, which I think is a very accurate term. I don't hear that with this, but the crosstalk I could mention, and I could measure, because worst case crosstalk on the MBox Pro, and I mean worst case, was the highest frequencies, the most amount of crosstalk was minus 84 dB. Now, minus 84 dB is way down there. That's pretty much the dynamic range of the CD. A CD's dynamic range is, in theory, 96 dB, but there's noise, there's converter noise, there's, you know, other things that raise the noise floor. So you're really looking at, depending upon the quality of the CD, 84, 86 dB, something like that. So, and bear in mind, 84 dB was the worst case. If you went down closer to the mid-range, it was actually more than that. It was down into the 90s and the lower 90s. And why is that important? Well, having high frequencies, they're what determine the separation. They're very directional. Bass, kick, they're always in the center because they're not very directional. The high frequencies are the things that define the space of that soundstage in a lot of mixes. So if you have crosstalk that's like 50 or 60 dB, which I have measured with quite a few interfaces, that's a respectable specification, but it's not an excellent specification. Minus 84, worst case, is an excellent specification. So if you listen to this and you go, yeah, the soundstage just seems a little wider, there's a valid technical reason for that. Another specification that surprised me on this was the intermodulation distortion. And again, without getting too deep into that, the way you measure that is you put in a really strong 60 hertz signal and a really strong 7K hertz signal. And in an ideal world, these are sine waves that are non-distorted, and you would see only energy at those two frequencies if you looked at it. But this isn't an ideal world, as you've probably figured out by now, and they will interact to some degree and create distortion components. So then the question is, how many components do they create? What levels are they at? And in this case, when I ran the test, I thought I must have done something wrong because it didn't square with, you know, what I'm used to seeing. I thought maybe I had the levels set wrong, or the signals, the 60 and the 60 hertz and 7K hertz tones were off or something. So I ran the test again, got the same results, ran it again, got the same results. And basically what it ended up is that I only saw two distortion components. There was one, if I recall, I think it was 120 and 180 hertz. The 120 was lower than minus 110 dB. And the 180 was a little bit higher than minus 110, like minus 108 or something like that. And that, I mean, that's really low. I mean, that's really down there. And I could not detect any other obvious distortion components because they were down in the noise level itself. Now, the noise level on this, again, talking worst case, everything, all noise components were below minus 120 A weighted. But in a lot of cases, it was below 130. In other words, the noise isn't constant across the spectrum, and there will be variations, you know, within the frequency spectrum, and that's why you see plus and minus X amount when you see specs. But nothing was higher than minus 120. A lot of it was down around minus 130. So any additional components of distortion were hidden by the noise floor. I mean, you just couldn't see them in there. And that to me was quite impressive, and again, something I haven't seen in a lot of units. How they kept that down to that level is, I don't know, but I could see it, I could measure it. Total harmonic distortion, the specs were also excellent, but that also tends to be good in other interfaces as well. And most interfaces have reasonably good noise levels these days, at least minus 110, minus 116. But this is what I mean about you do things a dB or two at a time. You know, you have just a little less distortion components that are masked by the noise, that are lower and fewer of them than other ones, with a slightly lower noise level, with a slightly lower this, a slightly lower that. By the time you add all those slightly lowers together, you have considerably lower.